Hello and welcome to the Ultimaker S5 Pro Bundle tech demo. So my name is Matt Griffin. I have been at Ultimaker for 5 years and in the desktop 3D printing world for 10 years. And today we're going to spend a lot of time doing something I'm really excited about. We're going to go through all the details of what's happening in the Ultimaker S5 Pro Bundle. And I'm really thrilled that today we have a guest from Ultimaker R&D who's going to help us really see under the hood, understand what's going on right now while it's printing, and also some of the decisions that went into making the Ultimaker S5 Pro Bundle.
Hi Matt, well thank you. My name is Arend Jan van Lent and I'm an industrial design engineer. I've been closely involved with the development of the S5 Pro Bundle, so the peripherals, the material station and the air manager for the S5. I hope I can answer all your questions.
Fantastic. Thank you for spending time with us today with this. Okay, so the Ultimaker S5 Pro Bundle is composed of 3 components. You have the material station at the bottom. You have the Ultimaker S5, which has been out for over a year and now has gained all this capability through these accessories. And you have the air manager up on top. So we're going to go through this sort of following the path that material goes, coming into the machine and all the way to, sort of venting out into the filter at the top. So we're going to start with the Ultimaker material station. So what is the Ultimaker material station? What were the problems that R&D was looking to solve with creating this?
So the material station is an add-on for the S5 that stores up to 6 spools of filament for you, and it doesn't just store them, it will keep them fresh, moisture free, and also it can automatically load those materials up until the S5, and when the S5 is done printing with them, it can load them back down, and then the system is ready to start with a spool for a different spool for a subsequent print job.
So one of the questions that we receive from customers all the time is, which materials are humidity sensitive and which are not? And we find that in general, a lot of polymers are humidity sensitive. So why did we go to the link to make this level of humidity control? How will that help printing?
Yeah, the one that everybody of course knows about is our PVA water-soluble support material, right? If that isn't moisture sensitive, I don't know what is. So, and a lot of feedback from the market has indicated people are not certain how long can they keep this. And also a material like nylon is quite sensitive.
Yeah, and many of our customers don't know that TPU, for example, is very humidity sensitive. And they don't even necessarily, they might not have known to store it in a way like this, and this really helps with processing.
So our colleagues from the print process team, they have determined what kind of moisture level is the maximum allowed, and the material station will keep all spools below that level,
and
regardless of the ambient, so below 40% relative humidity or 40% RH.
So we have the material station here, and we have 6 bays for materials. What is happening to keep the humidity? I mean, obviously, we need to remember to close the door when we're not using it, but what's happening actively to control the humidity?
Hidden from plain sight, there is a device in the material station that circulates the air inside the material station, around the spools. And in that device is a container of small silica beads, and they will absorb the moisture that's in the air. So as the air is being circulated, any moisture is being absorbed, so the air is dry, and that keeps the spools fresh and dry.
What happens when the silica beads fill up with humidity?
Yeah, they will get saturated at some point, and the machine detects it by itself, and it will trigger a regeneration cycle. Sounds fancy. It switches some valves and it changes from circulating the air inside to circulating the air outside. And as it's circulating outside, these silica beads are heated and the absorbed water is being evaporated and vented out on the back.
So
then they are dry, the valves switch back, and the air is again circulated inside.
Okay, so just to go over that again to make sure I understand it. So you have these silica beads, they become saturated with humidity. And then when you switch to the other cycle, they're heated up to release the humidity. Then how often does that happen?
It depends a lot on what kind of conditions are, what the ambient conditions are outside of the machine. But you shouldn't even worry about it because the device is fully autonomous. It's measuring the RH continuously and it will act accordingly.
And by switching back and forth, your silica beads are regenerated?
Yes, the water is vented out the back and they are again dry and ready for absorbing any new moisture.
Fantastic. So you have a material station that can stabilize your material to give you good processing experience. So let's start our journey through it. So you have this door here. And the door is really fun. There's something kind of satisfying about opening and closing it. It's a little bit like an oven door, but maybe on a spaceship. You were telling me before when we were going through this that there was intention to the angle for the door.
Yes, because we had some prototypes with the door opening up to an exact level angle. But what then happens is that people will start using it to put whatever they are currently holding, laptops, spools of filament, on that door. And it's not designed to do so. And also, well, then you can't close the door again. So, which you have to do to keep the spools fresh.
So even when we were experimenting with this to prepare this tech demo for you, we saw alerts coming up warning us, hey, you're supposed to close the door. You have to close the door, and it monitors that with a sensor inside to make sure that you're not missing out on the actual function.
Yes, and so with the door opening a little beyond level, it's clear that if you were to try and put something on, it might slide off. So it's preventing that kind of misuse.
Yeah, it helps remind you. Yeah. Okay, so right now we're printing with the first two materials, the silver and blue PLA, a project up here that will take many more hours to solve here. But we're able to actually open and add and remove other spools as we go, which is pretty excellent. So, you know, maybe this job lasts several days and I want to plan for that next job. It's pretty exciting that you can get in there and do that. So let's talk about these actual bays. So I can pull out this tough PLA. So what are the parts of this bay? Like I can, yeah, go ahead.
Yeah, so what you can see is there's some rollers on there that will help the spool for the unwinding of the filament. And there's actually a roller in the back as well. And that roller is motorized. And there's the entry funnels for inserting the filament into the system. There's an eject button. And there's a top component that will also help keep the spool nice in place.
And it makes for a pretty satisfying sort of insertion. You sort of slide it in there like this, and you can tell it's where it should be. So talk to me about, I can put this in the first funnel and I can load it. And I feel the mechanism grab the filament and pull it in a little bit further. What's happening there?
Yeah, so there's sensors just behind the funnel, and they will tell the moment you insert the filament, and those will activate a pre-feeder, which is like a traction module behind the funnels, and they will start to see if they can accept the filament that's being offered. Then a second sensor can tell whether that was successful or not. So that's now has happened. The filament is ready. And the insertion also triggers a NFC antenna that's in these little separation walls to see when you are using the Ultimaker materials, if there is a tag available, and then what material you actually loaded.
When we were talking before about the NFC chips readers in the fins, you mentioned that it can be challenging to be loading 6 materials all so close to each other. Tell us a little bit about some of the problem solving to make that a seamless experience.
Yes, because we wanted, of course, to put as many spools of filament in the machine as we could fit. It made these antennas very close next to the spools, all the spools close together. So a single antenna will see multiple spools of filament, and then it doesn't know which one is located where. So there was a neat trick, and that's the sequential scanning of the antennas. And by telling at what point a single antenna sees what spools and adding the logic of that sequential scanning in there, it can tell which spool is located where.
You showed me something earlier that I didn't even notice having used it, which is definitely a sign of good user experience. When you open this, it goes right to the configuration panel on the S5 itself to show the process of loading that new material. You can correct it if it's wrong. I've been using these for a bit, and I never noticed that because I wanted to always change that next thing, and it puts you right in the screen ready to do that. So this one right here that's not currently recognized, you can click on it, and you can select the type. And I know it's PLA because we put a little short end in there, and it will sit there and identify it. Okay, so here we have spools loaded. I'll close this so it doesn't yell at me too much about ruining the humidity protection inside there. What happens after it pulls it in? It recognizes what material, either through the NFC reader on the side or through selecting it in the interface here. What happens if we are printing from that spool right there? What happens next to the filament?
Yeah, so the S5 gets its print job, right? It's either you using the screen and a USB stick to start a print job, or it can get one via the cloud, and then the S5 knows what kind of material it needs. It's in the print job, and it actually orders a material from the material station. So it tells, please hand me over the material in spool labeled C. And then that pre-feeder correlating to that bay is activated, and it will start feeding the filament through the material station and up the back of the machine into the feeder of the S5. And then the S5 feeder, it's running, and it's picking up the filament as it's being offered. And at that moment, that is being detected, and the material station basically turns into a slave device, and it will offer filament as it is requested by the S5, and it will also pull back filament if the S5 is returning it.
That makes a lot of sense. So, so right here, we have the job that we're printing right now, this headphone stand. So it indicates that in the first extruder, it wants PLA blue, the second extruder, PLA silver. So it requests that those get loaded into the S5, and then it's ready to print. So that takes us up to the S5 itself. So the S5 is at the core of the Pro Bundle. It is the S5 Pro Bundle because it's taking our most popular machine to date for manufacturing and engineering and adding further function and capability. So talk to me about how the S5 in the Pro Bundle behaves a little bit differently than it did as a standalone unit.
Yes, well, if you have an S5 standalone, you're first manually loading the materials on the back, and those materials will be put into the feeders and loaded into the print core. But the idle state of a standalone S5 usually is with two materials in the print cores present. As opposed to when you have a Pro Bundle, then the S5 usually is empty. There's no materials there. They're all in the material station. And if a print job is started, it orders those materials and they get loaded up towards the S5. And then at the start of a print job, to make sure there's no remaining residual filaments from a previous print job in there, it will start a purging routine.
Now, so if you've never used the Pro Bundle before, it might surprise you. It's a little bit mysterious. It will have another sort of stage before it starts printing. And this is what you're talking about, this priming process that really makes it safe to count on loading any material at any time. Can you tell us about the priming and depriming process?
Yeah, so what it does, it's a process where we are ensuring that any remaining filaments from a previous print job is first flushed out completely. And so it does so by extruding some filament next to the build plate, and it will drop down in the machine. And by doing so, we make sure there's only the filament in the print core that you use for that print job, and that you end up with what you wanted to print in the first place.
And so why is it important to get it out of there? What happens if you don't clean the cores like this?
Yes, well, there could be a residual amount of material in there in a different color or of a completely different kind of plastic. And that can mess up your aesthetics. It could mess up the bed adhesion. And, well, your print simply is not the thing you ordered.
I know from years of printing with this kind of technology, you do have to purge the head a lot of the time when you're switching between dramatically different types of materials or colors. And so you usually do that work yourself. And now the automation system will just do it for you, maybe when you're not even there, which is really nice.
It is so convenient if you're doing back-to-back printing in different colors or different materials. It's fire and forget. You pick your print job and it will load the materials by itself, no matter what was in there before, purge the previous material out, and it will start with a clean start.
So talk to me about this. So now if you have an S5 and load the latest firmware, there's a whole layer of resource that's available to you here if you plug in the other components. You plug in the material station and the air manager and activate them. Tell me about this configuration screen, how it came about, what the goals were for having this kind of interface on the S5.
The interface was designed to mimic the spools below. There are 6 on a row on the screen, and there's also 6 spools in a row in the material station. And you can very easily see what material is located where. And the lines actually show the routing of the materials towards the corresponding print cores.
So when you were talking about making it possible to load in any configuration in these 6 bays, you've talked before about the efforts that went into making that double manifold. So you could route things from any position and have them end up in the right head. Well, let's take this further. So how are you seeing the customers using this? What is made possible by having the flexibility of addressing any bay to any head?
Yes, it's been a hot topic in R&D itself, and also in discussions with product management colleagues. How are people going to use this machine? And to be really honest, we didn't know. And then to limit yourself to a configuration of the machine doesn't feel right. So we tried, and we managed to support all possible combinations. So depending on your intended use, you could either select 6 different materials, all build materials, or 6 colors if you're doing a lot of visual prototyping, or you can only use 2 build material and lots of different support materials. It all depends on your need, and you can, per bay, per individual bay, choose whether it should be used on the first or the second print core.
Okay, one of the things that is possible that has made a difference for me already with the Pro Bundle is that if you have loaded more than one spool of the same material and one of them rolls out and runs out of material, the machine will pause, and instead of waiting for me to travel back into town and go and add another spool, it will automatically go to the next bay that has the same material, load that material, and keep going. This seems like a very powerful resource. How did you all make this possible in this machine?
Right, so in order to create that functionality, we needed to power all the bays. We have 1 pre-feeder per bay. So each filament can be fed towards the S5 and also unloaded from the S5 and parked back into the material station. That's just the technical driving of the filament. What we also needed was a reliable way of handling the filament inside the S5. Because in order for those materials to be reliably unloaded and subsequently loaded back into the printer, you need to make sure you can actually pull the filament out of the print core in such a way that you don't end up with some stringy tips or pieces breaking off. So there was quite a lot of effort gone into getting what we call the deprime parameters, or the deprime recipes, inside the S5. Imagine you try to pull the filament out of a hot print core. You will immediately pull this long string. But if you let them cool down to ambient temperature and try to pull them out, they will be stuck inside. So for every Ultimaker material, we have designed working parameters to reliably get this material out of the print core.
So now you can load whatever material will follow right into the same head, even if it's the same material, maybe it's a completely different type of material, and keep printing. Okay, so now we're up here at the Air Manager. So what was the challenge that Ultimaker R&D was looking to address with the Air Manager?
The challenge, the ultimate goal, was peace of mind. Printing a plastic material gets these ultrafine particles out into the air. And doing a real quantified statement about that is always very difficult. It depends on the object you're printing, it depends on the material that you're printing, it depends on the size of the room and the amount of ventilation inside. Is it the only printer in there? Are there other machines in there? And the Air Manager filters up to 95% of all ultrafine particles that come from this printing process itself and ensures you're in a safe environment.
So it is perfectly safe to print all the Ultimaker materials on a machine without the Air Manager, but like he's pointing out, you can actually set up a cluster with a lot of machines gathered together without raising the saturation of those ultrafine particles in the room to an area of concern. So, so this is a real help. And in here to help make this happen, there's an EPA filter that filters out 95% of the ultrafine particles, as he was saying. And the filters, they last a long time. You can get 1,500 hours of printing use before you need to change them. So that's a lot of printing. So you have this to keep your peace of mind, print whatever material you want and not think about it, and make your nice little print cluster of 20 or 30 machines right next to each other without worrying about it.
And look at it as much as you want from up close.
Fantastic. So one of the other things that you get from the Air Manager that I think is a big deal is it also protects your print that you're processing from the environment around you. So this allows you to put the machine wherever you'd like and not worry so much about where the HVAC units are and whether a door opening, closing is going to send drafts through. So this gives you a lot of freedom to put them where you want and have as many as you want. So we've gone through all the component elements of the Ultimaker S5 Pro Bundle, the material station, the S5 itself, now powered by firmware that gives it this additional function, and the Air Manager. And so where we're taking this next is pretty exciting. One of the things that we have been talking about as we've been talking about the process of making this machine and all the work that keeps going into this is that this is not the final fixed state of the Pro Bundle, that there's continuous improvement happening. Tell me a little bit about what's happening at R&D to explore what's possible with this machine.
Yeah, what's so nice about working for Ultimaker is that all the parts required to get, in the end, the printed object are developed in-house. So we have our own software development team, we have the hardware development team, we're working very closely together with the material manufacturers, and those all help to ensure that we get both the printed part quality, but also the user satisfaction, the user journey, the workflow that we like. And we've always done that also for the older machines, that we've always been continuously improving on allowing the user to use the machine the way they want to in a nice and hassle-free way. So for the future, we'll continue on working to get the machine to a higher level of productivity and easier to use.
So we're recording this tech demo pretty close to the beginning of the Ultimaker Pro Bundle's launch. And now that they're out there in the world and are being used by a lot of people, some of those 28 million combinations of potential configurations are being tested and explored. Material partners are working with us to refine those Pro Bundle specific profiles that will allow you to do even more when printing in this configuration. There's a lot more to explore and see in the future, and more optimization and capability. So thank you again so much for coming and joining and sharing some of these crucial details about what's happening under the hood with the Pro Bundle. Thank you very much.
You're more than welcome. Thanks for having me.
If you have more questions about Ultimaker, the Ultimaker ecosystem, the S5 Pro Bundle, check out our website. And there you can request a quote, you can reach out to us, and we would love to follow up with you.